Hello and welcome. In this video, we'll talk about factoring a sum or difference of cubes. This lesson has been prepared for students who are taking the grade 12 Advanced Functions course, MHF4U, but it can also be used by students who are taking the grade 11 Functions course, MCR3U, and maybe by students who are taking the grade 12 Data Management course, MDM4U. So let's get started. There are two formulas that we're learning in this lesson. One is the sum of cubes and the other one is the difference of cubes. If you learn one of the formulas, then the other formula would be easy to remember because they're pretty much the same. I'm going to get started with the first one. So we call this a sum of cubes because we are finding the sum of two cubic terms. There are two factors we can factor this sum of cubes into. One is in binomial form and the other in trinomial form. Whenever we have the sum of cubes, the binomial form factor, so the first one, we'll have the terms connected by the sign plus. So we'll see the sum of the terms a and b. So a plus b is the first factor. And we said the second factor is in trinomial form. And not only that, but it will be easy for you to remember if you think of it as the perfect square trinomial because it looks pretty much like it. Remember that a perfect square trinomial starts with a term squared and ends with a term squared, and so does this factor in here. But unlike the perfect square trinomial, the middle term, it's not 2 times a times b, but it's simply a times b. Now, one last thing we need to take care of is the signs. So when you have the sum of cubes, this is a plus, this will be a minus, this will be a plus. So we're going to have a minus. And you know what? I'm going to make it a special color just to get your attention there. Okay? So you have one negative term, and that would be the middle term in the trinomial factor. So now let's move on to the difference of cubes, so the difference of two cubic terms. Again, we are in a similar situation. We have one binomial factor and one trinomial factor. So because we have the difference of cubes, so the minus sign between the cubic terms, then the first factor will have its terms connected by a minus sign, just like in here we had plus. And then we write a minus b. Now the other factor will be very similar to this, except for one thing. This plus will change into this minus will change into a plus. So then we have a squared plus ab plus b squared. So everything else stays the same. So we are going to take a look now at several examples, and they vary actually from quite easy to a little bit more complicated as we move along. Why not? So the first one, x cubed minus 8. What we want to do is write each term as a cubic term. So x cubed will be x to the power of 3, and number 8 is 2 to the power of 3. We want to do this so that we can easily see the values of a and b in our polynomials, in our difference of cubes, to be more specific. So the value of a, oops, this wasn't supposed to happen. So the value of a is x, the value of b is 2. So we're simply following the pattern that is provided here by the second formula. That's because we have a difference of cubes, right? So here goes our first factor, which is in binomial form. And here goes the second factor, which is in trinomial form. The a value is x. There goes x. The b value is 2. There goes 2. We have difference of cubes, so x minus 2. The next factor would be x to the power of 2. Last term, 2 to the power of 2. Middle term will be 2 times x, or x times 2, same thing. Because we are in a difference of cubes, the terms in the trinomial will all be positive, so plus here and plus there. Now I'm going to write this in a neater form. Obviously, you don't have to show so many steps. You can just jump ahead and write the last step. That would be sufficient enough. And I'm just simply writing 2 squared as 4. And this is it. We're done with this question. Moving on to the next example, we have 27x cubed plus 125. So what we want to do is write this binomial or sum of cubes as powers of 3 for each term. So 27x cubed is 3x in brackets to the power of 3. Remember the exponent rules, right? So 3 brings this to a power of 3, this base. So it applies to each part of the term. And the next one, 125, will be 5 to the power of 3. So there go our values of A and B. And the factored form will be a binomial and a trinomial. I'm going to use square brackets in here. You'll see why. So we have the sum of cubes. So that means the first term or the first factor will be 3x plus 5. Now the second factor, which is a trinomial form, will be the first term, 3x squared. And then we have a minus this time, right? The product of the first with the second, so 3x times 5 or 5 times 3x, and then plus 5 squared. And I'm going to write this again in a neater form. So we'll polish just the second factor. 3x squared is 9x squared. 5 times 3 is 15x. And 5 squared is 25. And we're done. Next example. X to the power 9 minus 15. So difference of cubes, but I want to make the cubic terms more visible to myself. And for this, I'm going to have to write x to the power of 9 as x power 3 cubed and 512 as 8 to the power of 3. So now I know that the a value here will be x to the power of 3 and the b value is 8. We have the difference of cubes. So that means our first factor, which is in binomial form, will have the terms connected by a minus. And we have x power 3 minus 8. The next one is, well, you know what? Let's make the brackets square. Since we're here, why not? So we have x to the power of 3 squared. And then plus the product of the terms, so 8 times x to the power of 3, and then plus 8 to the power of 2. So write the equation in a cleaner form here, x cubed minus 8. And then the next one will be x to the 6 plus 8x cubed plus 64. Now, one thing I want to assure you of is the fact that this one is not going to be factorable, okay? And that is the case all the time. However, we should always check for the first factor, which is in binomial form, because sometimes it can hide another difference of cubes or sum of cubes. And in this case, it does, because as you see here, we have the first a cubic term, x to the power 3, and the second one is a cubic number, which is 2 to the power of 3. So we're going to go one step further and factor x cubed minus 8 as, we already did this in the previous example. Actually, we have it factored already, x minus 2, x squared plus 2x plus 4, and then x6 plus 8x squared plus 64. And in this case, we factored this difference of cubes into not just 2, but 3 factors. That's the way it worked. So we're moving on to our next example. In the next example, we have 7x to the power of 4 minus 448x. So this looks a little bit suspicious to me because it doesn't look like the sum or difference of cubes. So I should say difference because I see the minus sign in between the terms. But then if you look into it more closely, you see that these two terms have a common factor. And if you remember when you were taught factoring for the first time, we said that the number one step we must take is check and see for a greatest common factor. That will make the terms less heavy. So it will simplify the coefficients and all. And what we see in here is that the variable x is a factor in both terms. That means we can take that out. And we can check and see what happens to number 7, because 7 is not a perfect cube number. And ideally, we wouldn't want to have that. So we are hoping for 448 to be divisible by 7. And if you divide it 448 by 7, then you'll find out that would equal 64. So that means that 7 is a factor of 448 as well as the first term. So we're going to take that out. And we have x to the power of 3 minus 64. And here we go again. Now we can see more clearly that we have a difference of cubes. Do not forget 7x is still a factor of the expression given. And we'll have x to the power of 3, and 64 is a cubic term, 4 to the power of 3. I'll make this pink just because we have used the same color for it. So we are going to factor it as x minus 4 times x squared plus product of 4 and x, 4x, and then plus 4 squared, which is 16. And we're done. So we had 3 factors in this case. So one was the greatest common factor, and then the other 2 factors of the difference of cubes. By all means, feel free that you stop the video and try the examples 5 and 6 on your own. It's always fun to do things on your own, and you can check the answers later. Okay? In the meantime, I'll continue working here. So